Okay, this is the last problem of the example. It has a I shape, also known as a wide flange beam, and it's subjected to a shear force of 20 kilonewtons, and I wanted to know what the shear stress in the web is. It says at a specific point A. The specific point A is at the top right here, right at that interface of the flange and the web. This, in my opinion, actually makes it easier. So I've drawn basically what is going to happen. We want to know at this point right there. So we could choose the bottom or the top. Choosing the top makes it way easier. That's why I highlighted it in red. So the first thing to do is like the last problem, we need to figure out the overall moment of inertia of this entire thing. I know the last problem was a little bit of a grind, so I just gave it to you. Here's I of this little shape. It's 0.25 times 10 to the negative third meters to the fourth. Cool? So now I need to get y bar. Y bar from the centroid. The centroid is in the middle. These guys are symmetrical, so it's just going to be in the middle. I've drawn half of the shape, and 0.15 is up to that point A. I got that by just doing 300 millimeters divided by 2, gave me 150 millimeters and converted it to meters. Okay, so the y bar from here to the point in the middle is 0.15 plus half of the thickness of this flange. And the thickness of this flange is 20 millimeters. So is just going to be the 0.15 meters plus 0.02 meters divided by 2, which gives me 0.16 meters because this just becomes 1.01, and I add that to that. So I got 0.16. And then the area of that little guy is just going to be 0.02 meters times 0.2 meters. I just got this information. It's 200 millimeters long, and that gives me the 0.2. This one should be 0.02. So this is 0.02 long, and then its width is 20 millimeters, which is 0.02. So I do that, and this gives me 0.02 times 0.2 is 4 times 10 to the negative third. Looks like I got a Facebook notification too. Face 4 times 10 to the negative third. I said 4. Cool. And that is in meters squared. And now I could get Q. Oops. Q is just that A to, this is AP. AP times Y. And so I do all that math and I get 0.64 times 10 to the negative third meters to the third. Now I can multiply that all into the overall shear equation. T equals BQ over I T, and B was 20 kilonewtons, or 20,000 newtons, times the Q of 0.64 times 10 to the negative third meters to the third. All that divided by I, which we just calculated, or I gave you actually, of 0.25 times 10 to the negative third. All of that by the thickness of 0.02, which is the thickness of this web right here, 20.02 meters. I do all that, and if I leave it like this, I'll get a big number, which converts to 2.56 megapascals. And that's the answer to this problem. Again, I just wanted to all to be able to realize that we need to get a Q through AP and Y bar, plug that into the equation. You'll eventually need I, which will probably be given to you or be a simple shape, actually. So I need to highlight everything here, and that's it. That's all these problems for these examples.